find the perimeter and area of the regular polygon. Okay, this regular polygon is a square, so we can use some properties of this, which, for instance, we know that each one of the angles is 90, so therefore this angle right here is 45 because it's being cut in half. So this top one is also 45. Lucky for us, that means that we have a special triangle right there, and we can use the rules of special triangles. So since the 6 is the hypotenuse, to get to one of the legs, we need to divide by square root of 2. So 6 over square root of 2 is the length of this piece. So, but we need the full length of the side, so we just multiply that times 2. So we have 12 square root of 2. Now, we're not going to worry about rationalizing this at this point in time. It's in the middle of the calculation, so let's not worry about it. Let's just do the two formulas. So we have perimeter is 4 times this number, because each one of the sides are this length, and there are 4 sides. So 4 times 12 over square root of 2. Okay, so that equals 48 over square root of 2. Now, if we wanted to leave it in terms of square root, we would have to rationalize the final answer. So I'm going to do that right now, just so you see how to do it again. So multiply top and bottom by square root of 2. So 48 square root of 2 over 2. So that's 24 square root of 2. Okay, our problem does not have units given to us, so you can put units square, but I'm really not worried about it, if they don't give it to you. So, since this is a square root answer, for those of you who love answers that are not in terms of square root, the answer for this would be 33.95. Okay, so that's the perimeter. Let's find the area. So the area equals base times height, or length times width. Now, since it's a square, it's side squared. So 12 over square root of 2 squared. So the top will be 144. The bottom will be 2, because square root of 2 squared just gives us 2. And so this is 72. So that's the surface area of this figure. Okay, our next figure is an equilateral triangle. We know that because they told us it was a regular figure. So recall that each one of these angles in an equilateral triangle is 60. So therefore, this angle right here will be 30, because it's half of that. And so this will be 60. Lucky again, we have a special triangle. So it's a 30, 60, 90. So remember, if we go from the shorter leg, which is this piece, to the longer leg, which is this piece right here, we multiply times square root of 3. So 6 square root of 3 is that half of the side. So the full side is going to be 12 square root of 3. So let's just use that side length. So the perimeter, again, is going to be a number of sides, which is 3, times our side length, which is 12 square root of 3. So that's 36 square root of 3. Okay, so that's in terms of square root. But now let's say we wanted a decimal answer, so this would be about 62.35. So that's our perimeter. Let's do the volume, not volume, but area. So the area, remember, we have a special formula for the area of an equilateral triangle, 1/4 square root of 3s squared. So let's plug in our side length. So that's 12 square root of 3 and squared. Okay, so let's work this out. Let's plug it in our calculator and just get the answer for this. So actually, in terms of square roots, it's going to be 108 square root of 3. So we can figure out what the decimal answer is going to be, and that's about 187.06. So that's the area of this equilateral triangle. Okay, so our last example is this hexagon. So again, we remember that hexagons have equilateral triangles, and we have a side length of 8. So let's use the formula for equilateral triangles. So we have 1/4 square root of 3 times side length squared. So that's 8 squared. And since we have 6 of them, times 6. Okay, so let's work this out. So we have 64 times 6 divided by 4 gives me 96. Square root of 3, which is about 166.28. Okay, so that's the area. Now the perimeter is really easy since we have the equilateral triangles. Each one of these sides is 8. So, and we have 6 of these sides, so 6 times 8 will be 48.